Explain why inverse cosine of 5 over 13 is equal to inverse sine 12 over 13 is equal to inverse tangent of 12 over 5. Well, first let's start off with a 5, 12, 13 triangle. So we'll have the base is 5, the height is 12, and the hypotenuse is 13. We have cosine of theta is adjacent over hypotenuse. Sine of theta is opposite over hypotenuse, and tangent of theta is opposite over adjacent. Now if we take the inverse cosine, sine, and tangent, we'll be solving for what that angle is. So if we take inverse cosine of both sides, we have inverse cosine of 5 over 13 is equal to theta. Inverse sine of 12 over 13 is equal to theta. And inverse tangent of 12 over 5 is equal to theta. So what we showed is that all of these three inverse trig functions are equal to the same angle theta. And that's what we wanted to show, that these three are equal. Now for number 2, without doing any algebraic manipulations, explain why 2 cosine squared minus 1 quantity squared plus 2 cosine sine quantity squared is equal to 1. Well, first notice that 2 cosine squared minus 1 is cosine 2 theta. And then 2 cosine sine is sine 2 theta. Okay, so we know the formula sine squared plus cosine squared is equal to 1 for any theta that's a real number. So you're basically going to replace theta with 2 theta. Or if you want, you can write this in terms of x first and let x equal 2 theta. And so you would just get sine squared 2 theta plus cosine squared 2 theta is equal to 1. For 3, explain why there does not exist a real number x such that 2 to the sine x is equal to 3 over 7. Well, here we want to solve for x, so let's take the log of both sides, since that's going to bring down the exponent. And now we're going to divide both sides by ln of 2. Now, if we plug in our calculator, what is ln of 3 over 7 divided by ln of 2? We get negative 1.22. Now we know that sine oscillates between negative 1 and 1. So if you look at the graph, it's going to look like this. So at negative 1.22, there's nothing there. It's empty here. Sine never equals negative 1.22. Therefore, there's no solution, no real solution. For 4, explain why the equation sine squared minus 4 sine x plus 4 equals 0 has no solution. Well, if I factor this out, I get sine of x minus 2 quantity squared is equal to 0. So that's factoring this thing on the left. And if I take the square root of both sides, I get sine of x minus 2 is equal to 0, and sine of x is equal to 2. But if we look at the graph of sine, we know it's never equal to 2. There's nothing here at 2. So there's no solution there. For 5, explain why the expression inverse cosine of pi over 3 makes no sense. Well, for inverse functions, we take in a length and spit out an angle. So for this one, we know that in general cosine of an angle is equal to a length. So when we do an inverse cosine, we reverse it. We take in a length, spit out an angle. So what this says is the length is pi over 3. Well, we know that pi is about 3.14. Divide that by 3, that's obviously greater than 1. So what this is saying is, find an angle theta such that the length is greater than 1. In other words, pi over 3. But cosine also is between -1 and 1. And it's never greater than 1. Pi over 3 is somewhere up here. There's nothing over here. Therefore, this makes no sense.